Good morning, everyone. Today I want you to present my work in forest sorghum in the northern latitudes. And forest sorghum, is grown for forage here in this area, and it's been bred for high yield, but also some characteristics that increase nutritive value. And we call forest sorghum, but many of them are mixes with sorghum Sudan grass and other mixes. Now the goals to breed for an energy crop are not any different than when we're breeding for a forest sorghum, because you want a high yield, hopefully in one cut in case of energy. Forage nutritive value or chemical composition will help conversion and to adapt to northern climates and chilling tolerance. So why is forest sorghum? We've worked with sorghum for over 10 years in North Dakota, and it's by far the highest biomass yield crop, including perennials, has tolerance to drought, and lower inputs, lower greenhouse gases emissions, lower lignin content, which aids with conversion and can replace in part the corn silage for biogas. We wanted to relate a little bit this with sorghum as a feedstock and climate change. This is a study done by Kukal and Magna in 2018, and they evaluated the annual growing degree days based 10 degrees Celsius temperature. We're in about this area. And then the trends due to climate change in our area are either not changed to 300 growing degree days more. And so we wanted to see where the sorghum kind of fit in our area. So the objectives and research question we have is to determine this biomass yield potential in cultivar hybrids grown in north latitudes and the correlation with growing degree days and types of characteristics of sorghum. How many growing degree days, base 10 or 15, we need to plant and from plant to harvest to produce a yield of 15 megagrams of dry matter, and what types of sorghum varieties, characteristics we need for high biomass yield to create these agrozones where forest sorghum can be grown as feedstock for energy. So for the methodology, we have over 10 years of data of forest sorghum trials with different types of entries and collected. So collect all this data and organize it. And for North Dakota locations, we have 47 north latitude, calculated growing degree days at 10 and 15 temperature, recorded planting harvesting days and frost dates, recording the characteristics of type of sorghum, if it had a special characteristic like brown meat rib, which is a low lignin, or rachitic with very short internodes, and analyze and visualize this information. And the next step will be to search databases for sorghum research in northern latitudes that has forest yield and hopefully weather data. We can correlate the growing degree days with our work. So this is all the data. We have over 1,000 data points from 2009 to 2020, and you can visualize here that there's a lot of variability. The median of all this data is 13.7 megagrams, and the mean is 14. But we have some genotypes with really, really high yields and some with lower yields. And you can see that the year makes a big difference. We didn't have the same number of genotypes every year, and but this is the data we work with. But we can see that we have several genotypes there above the 15 megagrams, pretty much in every year except for 2009, which was a very cold year. So when we correlate this and put the growing degree days, base 10 and 15. So the first number is base 10 degrees Celsius, second one is 15 degrees Celsius. And we can see that one of the things we can see here is clearly the range of growing degree days that we see for each year from planting to harvest is very narrow. For the base 10, it's only like 300 growing degree days difference, and for the 15, it's only like 200. So we have a very narrow, really, level of that for this data. So it's hard to correlate it with yield. Okay. So here you look the 3 hottest or warmest years according to growing degree days, and their median yield or average yield It's no different than years that have much lower and the lower end of this range. But one thing we can see, we got at least 2 environments where median and average are above that 15. And like I say again, there's genotypes in every year, except 2019 above the 15 megagram goal of yield. So we try to correlate it. And of course, there's no correlation between yield and growing degree days, but the temperature, and that's not a surprise. We got a very narrow range of them. We also wanted to correlate growing degree days at 10 and 15. It's not a perfect correlation, and that's because at the end and the beginning of the season, the accumulation might be different. You know, we might accumulate at 10 degrees and not at 15. Okay, but this is really not a surprise. This is from the same study, studying climate change and growing degree days that I show you. And this graph is for sorghum, but sorghum grain. And you can see that here they regress growing degree days with yield residuals, and there wasn't much of a relationship either. And even here you can see that the lower values were in the 1500, which we are really in a different range here. We're much lower than that. So not much difference, our 15 megagram goal. Here you can see that if we can see here that we have 1250 growing degree days, we can produce 15 megagrams at that growing degree days. And according to this map and prediction, we do have that many growing degree days. Most of the year, these are the annual ones, the orange color, varying from 1000 to 1500, and that's annual, so it's probably a little less, but most of the growing season accounts for that amount. So we are right here, and with climate change, looks like we might be able to warm up a little more in this area where we are, but if we go to the east, there's some areas actually going to cool down, so we could maybe get off of that area where we need to be to produce sorghum. So why so much variability? Well, these trials weren't done for energy, they were done for forage. So we included many genotypes. They're forage types with forage sorghum, Sudan grass, Sudan sorghum grasses, sweet sorghum, grain sorghums, some with the BMR rachitic. And we know these characteristics, they are for quality, they're actually reduced yield. So this one BMR rachitic reduced 20–40% yield compared to the non-BMRs. Also the data, some of the data has 2 harvests, which is typical for forage. One cut of the season has usually 20–30% more yield than 2 cuts. Rainfall variability, of course, this has rainfall, and that's something we'll look at too. Some warm years are also very dry, which will reduce yield and it won't let us see that warmer weather produces more. Okay, and spring and fall frost, very important. Sometimes we get very early frost and sorghum dies before it can accumulate, you know, before it can actually produce more. So we went and took all this data set and filtered it out for non-BMR types. So only non-BMR types. That means we got rid of all the BMRs, rachitic, grain types, all the ones we know are lower yielding, and just kept those. The 2019-2020 data had 2 few points to keep them on the analysis. So we have it to 2018. And here, by changing this data, you can see median and mean both increase as we expected, right? Because we're eliminating the low yielding ones. And now what's interesting too, now 4 of the years we are above that line, right, of 15. At least 4 of the years we have mean and median above the line. And so, and we still have a lot of genotypes in every year that are above that line, and that give us the potential. So what's next? We'll keep filtering the data different ways and to analyze it, trying to identify those highest yielding types that we need to, that will need to be able to have forage sorghum as an energetic crop in northern latitudes. We'll compare those results, the results we're generating with forage sorghum trials in Europe and other countries and latitudes above 40, and hopefully they will have weather data that we can also do growing degree day correlation with the data, and then consider the factors that those studies have compared to our studies, and finally mapping the areas according to those growing degree days. And this, we hope, will be on the paper we'll publish out of this work, but we don't have that part done yet. So in conclusion, many forest sorghum genotypes exceeded the 15 megagrams goal of dry matter, even in years with the least growing degree days accumulated. I think we have already sufficient growing degree days in most years, most seasons, to exceed that. And then was no correlation between growing degree days and yield because of the very narrow range. And then we really think we have the potential to be able to select the sorghum genotypes from existing forest sorghum. It's very possible. And I really believe it's a crop with great potential. And thanks to everyone that worked over the years on my group, technicians, visiting science students. And if you have any questions, please reach me out. Thank you.